Hello YouTube, I am Arend Peter, and today I would like to share with you 6 tips to making an advanced level selection system in GameMaker. This is a follow-up on the 4 tips to making a basic level selection system in GameMaker, and I'm preemptively assuming that that first installment is going to be popular enough to warrant a part 2. For those of you who have not seen the first video, I'm going to take 30 seconds to go ahead and review what this is and show you our starting point. So, it's a very basic game. I just have a series of level buttons, and clicking the button will take me to the corresponding level. The game is pretty simple. I search the boxes, I find a key. When I find the key, I open the door and I beat the level. All of them are structured this way, except the keys are in different places. But the thing that we're going to focus on is how to organize these buttons and attach them to the room in an intelligent way. So, in the first video we discussed how to implement our buttons cleanly using a combination of parenting, room creation code, and a central level system. So right now we have a central level controller which keeps track of all of our levels, so we can modify which one our levels are by modifying them here. And then in the room, within the menu, I can right click on each of the objects, and within their creation code it indicates which level it's attached to. Alright? If any of that sounds like it would warrant more explanation, then you should watch the basic video first. If not, then we're going to move right along with the advanced video. So, tip number 1 for an advanced level system is to move all your code into level control. So right now we have been slowly moving stuff away from moving stuff away from the button objects to the point where we've got it all in the creation code within the room. But now we're saying, let's go all the way, let's create the buttons within the level controller, let's move all the code there. So we have even more centralized. This is the new main menu room. As you can see, there are no buttons in there anymore. However, if I play the game, there are still buttons in the game. And this is because in O-level control, when the room start event, I've checked for cases where it's the menu, and when it's the menu, I create the buttons in code. This is exactly what the room does, in that it creates a bunch of buttons at the X and Y values, and we handle the creation code here too by setting the variables through the instance we get back from the instance create function. You notice I'm using this var in front of these button variables. Var means it'll only exist within this area, which is nice because when people read this code, they know they don't have to worry about B1 existing elsewhere. B1 will cease to exist outside of the script because we don't need it after we've created the button. We don't need to refer to it through code anymore. Okay, so why would you do this, you might ask? Well, the person who requested this tutorial asked how we did this in Binary Dash, and this is actually similar to how we handled the levels in Binary Dash. We created them all in code, and this makes it much more scalable. So in Binary Dash we have like 40 levels or so. So 5 levels maybe aren't a pain to add in the main menu, but 40 levels certainly are a pain to manually add in the room. So when you're dealing with a large amount of buttons, scalability wise, it makes sense to go ahead and create the buttons in code. However, I want to make sure that I emphasize there's also a trade-off here. The more you create in code, the more scalable it is, but at the same time, the harder it is to make changes to it. So here I've defined where the buttons are directly to the X and Y positions, which is kind of tedious. And I don't get the same intuitive sense of where the buttons are as I would if I made them in the room. In Binary, I think I kind of went overboard. Even the main menu with the 3 buttons there were created through code. So it was really tedious updating it. What should have been a really quick drag a box to the left or right turned into like a big trial and error process of updating numbers in code. So there is a case where this doesn't make sense, but for a case where you have a lot of buttons corresponding to levels, it does make sense, which is why we're doing it in this tutorial. Alright, so that was advanced tip number 1. Advanced tip number 2 is to use arrays. So there's a pattern that we've been following. You organize code, and then once you organize code, you see patterns, and then you can reduce it. So moving the code here and centralizing it was organizing it, and there's more we can do to organize it. In this case, we have 5 level variables, and they all follow the structure of level with number at the end. So there's really like this big, larger concept of a series of levels, and we have subsets to them. Whenever you have that sort of pattern where you have a series of elements numbered, what you have there is an array. So if we go ahead and convert this over to an array, we can treat this as one array of levels rather than 5 individual variables. And as you'll see later, that helps us in a lot of different ways. So right now I'm going to go ahead and convert these to arrays. And now we're using arrays. So this is the create event where we created the levels, and I've included a comment with the old syntax. There's 3 major changes that we've done. Instead of doing singular level, we've done plural levels. Since arrays contain multiple things, it's standard naming convention to use plural to make it more clear. The other thing, instead of doing the underscore, I'm surrounding number in brackets. So that's the second thing. And the third thing is I'm starting at 0. Arrays start at 0 and count up from there. Unlike our other previous variables, they start at 1 and count up from there. It'll be confusing working with 0, but I'm confident you'll get used to it. Right now it's just a syntax change. You can see how I updated the room start. The formatting has just changed a little bit. But the cool thing about arrays is we no longer have to explicitly use numbers here. We can have variables set to numbers, and we can plug in the variables here, and then we can do all kinds of magic with arrays by referring to the elements as variables. In order to further sell that point and to show you how that magic can be wielded, let's go ahead and do some live coding and implement a feature request. So let's say someone plays your game, they go to level 1, they beat level 1, and then it takes them back to the menu. But they beat level 1, they kind of want to go to level 2. So the feature request is, instead of going back to the main menu every time, we want it to go to the next level. Okay, so the first thing we need to do is we need to have a variable indicating what the current level is. So right now we know which room we're in, but we don't know what the number level that is. We have to check through this array, which is kind of tedious. So in the create event of level control, I'm going to create a new variable. I'm going to call it level index, which is going to represent which level we're on. I'm going to initially set it to -1 because the menu doesn't have like a number assigned to it in this array. So when we click on the button, we want it to update this level index depending on which level the button is pointing to. So when we create the buttons, what I'm going to do is instead of having my level represent a room, I'm going to have it represent the index of the room. Alright, so now my level no longer means a room, it will be a number corresponding to that room. So right now we're at a little bit of an odd point. I'm no longer telling the buttons which room they should point to. I'm just giving them a number. But as we'll see in a second, they can use that number to figure out which room they need to point to. So I no longer need to directly supply them the room. The button can be smart enough to figure it out on their own. So if I go to the button object, this won't work anymore. What we can do here instead is we can have this variable refer to an element in the levels array. So I can say the following. So here you can see how powerful it is to refer to the elements of the array by a variable. If my level, let's say here my level equals 2. This right here will be equivalent to referring to this room zebra because it's levels 2. But instead of explicitly putting 2 here, we can put a variable which is equal to 2. This is something that we can do with arrays we would not have been able to do with the standard variable in practice. So now, in addition to having the button go to the level, right now nothing's changed. We also want the button to update that level index so that we have a concept of which level we're on. So we're going to say level control level index equals this new level. And to prove that level index is being set properly, we're going to have level control draw it. So I'm going to jump over to the draw event in level control and go ahead and add code to draw this. Alright, I've add this draw code. Now in the top left of the corner I can see that it's set to -1. And if I click level 3, let's see what it becomes. It becomes a 2. Which is good because remember the array indexes start at 0. So the 2 index is actually the third element in the array because 0, 1, 2. So as soon as we hit level 3, it's indexed at 2 because that's the third element. So now that we're seeing that's updating properly, let's implement our feature. So essentially when the player beats the level, we want to update the logic of which room it goes to. Right now the logic is in the player step event is if the x is bigger than the room width, it'll go to the main menu, but we want it to go to the next level. So what we can do is we can first off, let's increment the level index variable because that needs to increase. So we can do it like that. If you don't know plus plus, that's the same thing as plus equals 1, just a handy way to increase 1. And then in here, instead of going to the menu, we can again refer to the array, just like that. And this is even more powerful than the previous case of using variables. For the buttons, they get a variable and it never changes. But here we're dynamically updating the level we're pointing to. We're using the arrays to have like a more intuitive sense of the next level, this is again something we would not have been able to do if we were using the standard level variables. So if we test it out, we can jump over to level 1. We beat level 1. And we get an error. Oh yes, that was kind of silly. This is level controls, level index, not the player's level index. I'm trying to make this tutorial as streamlined as possible, but there will still be errors. Even though I'm trying to make this look smooth in the editing, never forget that there is a huge amount of trial and error, regardless of how long you've been coding. Alright, I've been using GameMaker for almost 10 years now, and I still make silly mistakes like this. So don't let stuff like this frustrate you. It happens. So if we test our feature, we go level 1, and we beat level 1, it works. So we can see the level index change the way we expect it to, change from 0 to 1, and the key is not in the same position as level 1, so we can verify that we did indeed go to the second level. Alright, awesome. Now we can get into advanced tip number 3, which is using loops in your code. Before we do that, I have 2 announcements I'd like to make about the description. First off, I've made a tutorial about loopizing code. Exactly what I'm about to do. I've made a whole tutorial about it. If you want more details, check out that video. There's a link in the description. Announcement number 2. All this code will also be in the description. And furthermore, it's going to be in the form of a GitHub repository, and you can browse through the commits to see the individual changes I made. So if you get stuck at a certain point in this tutorial, you can see all the individual steps in there. So check that out as well. Okay, so using loops in our code. Let's jump over to level control in the room start event. So as I mentioned earlier, we have this sort of consistent pattern of we organize code, we find patterns, and we reduce the code. Here we've been organizing them somewhat by first centralizing the button creation in one area, and then we've replaced the level variables with arrays. And now we're in a situation similar to what we were initially with having a bunch of button objects, where we have a bunch of snippets of code which look very similar if not identical. So whenever you have a sequence of very similar code snippets, the answer to fixing that is loops. So I'm going to go ahead and cut to the loop being made, and then I'll explain how it works. Here we've got the loop. I've left this code here for now, but in a second I'll be able to get rid of it all, because the loop does exactly the same thing. The way the loop works is, in this case, it's a for loop. There are a couple types of loops, but we're going to use a for loop. The way a for loop works is it executes the code within these brackets several times, and the rules on how many times it executes are defined within these parentheses. There's 3 sections to that. The first section is called initialization, where we initialize any variable we use to keep track of the iterations. In this case, I is the variable we're using to keep track of the iterations. So we start I at 0. The next section I want to talk about is this third section right here, which indicates what happens at the end of each iteration. So we're saying I++, we increase I each time. So the first iteration I is 0, second iteration I is 1, third iteration I is 2, etc., etc. And then we have this middle section, which is the condition. At the end of each iteration, it'll check this condition. If it's true, it'll keep iterating. If it's false, it'll stop iterating. So here we're saying keep iterating as long as I is less than 5. So first iteration I is 0. This will say, is I less than 5? Yes. Okay, continue. Then we are 1. I is less than 5? Yes, continue. And it'll keep doing that until we're at 4, and then eventually 5. Then at the end of the last iteration, it'll be 4. Then it'll increment and become 5. Then it'll check and it'll say, is 5 less than 5? No. So we stop. So this will go 0, 1, 2, 3, 4, and then it'll stop. So that's how this loop works. And as you can see, I'm referring to this I variable in here to account for any variations in the iterations. There are actually 3 sub-patterns in this code snippet. In order for this loop to work, we need to be able to express any variations in the patterns using the I variable. The first one is very simple. My level is equal to 0, 1, 2, 3, 4, which actually matches I exactly. So we can just say my level equals I. Very good. A little bit trickier is here we have level 1, 2, 3, 4, 5. It's not exactly equal to I, but we can do a little bit of math and just add 1 to I to be able to get these numbers. So as you can see, I'm setting the text to be level plus a stringified version of I plus 1. Now we get into a more complicated pattern. So the Y value of all the buttons keep changing as well. So it starts 64, then we add 96 to get 160, we add 96 to get 256, and so on and so forth. One way we can think of I, instead of being 0, 1, 2, 3, 4, we can think of as each iteration adding 1. So if we multiplied I by 2, for example, like if this was level times 2, it would be each iteration adding 2. So doing this will make it, instead of 0, 1, 2, 3, 4, it'll be 0, 2, 4, 6, 8. So with that in mind, we can do a very similar thing and say we start at 64 here, and then each iteration we add 96. So it's 64 plus 96 times I. If ever any of this seems confusing, you can just plug in I for the individual iterations and you'll see that it makes sense. Okay, so that's how our loop works, and then we can delete all of this, and that's very satisfying. We've organized the code, and now using loop we've reduced it. And now whenever we want to make changes to the logic, we can just change it here. As we continued saying, we have less code, which make maintenance easier, making it more scalable. Now that I've shown you how loops work, let's go ahead and implement another feature so I can show you more of the magic behind loops. So the next thing I want to do is, in this level menu, we want to have an idea of which levels we've beaten, which one we haven't beaten. So I want this text to highlight yellow on the levels we have beaten. So within level control, we're going to need to have an array similar to levels, only this one's going to be called beat, indicating which levels we've beaten. So we need to create 5 elements, and they all need to be set to false. And we do that very easily with loops in conjunction with arrays. Just like that, we've created an array and we've set all the elements to false. Pretty simple. Okay, now in the button, we need to update this font color if our level's been beat. And this is how that would look like. If this condition is true, if our level is beat, use the color yellow, otherwise use the color gray. Next, let's update the logic for updating the value of beat levels. So here in the player, when we go to the next room, we also want to set the current level to be beaten. Just like that. And in order to see whether the menu is updated, we need a way to go back to after we've beaten a level rather than just going to the next level. So we're going to add that here as well. Okay, now test our feature's been implemented. So I'm going to play level 2. I'm going to find the key. And now if I hit escape, we can see level 2 is golden because we beat it. Awesome. So as you can see, we're able to implement that feature using relatively few lines of code, and that's because of the work we put into using arrays and loops, and also parenting, because we were able to update the logic for all these buttons by only updating the one parent because of the shared logic. So that goes to show how useful these strategies are. Okay, now we've got another feature request. So we want a sense of score in the levels, so that in order to give more of a late game progression. So when I go to level, I want to have a score for how many of these boxes I leave unbroken. So this would have a score of 3 because I have 3 boxes unbroken. And then in the level, in addition to whether or not it's beat or not, I want text under it showing the highest number of boxes that are left unbroken. Alright, so this can be done very similarly to the previous feature, and I'm going to leave as a challenge for you to implement this. And this is what the feature would look like. I have the highest score of number of boxes left for that particular level. So if I play level 2, earlier it was 0. Now I find the key with 2 boxes left. So if I go back to the room, the highest score for level 2 is now 2. If you have trouble, check the code. Advanced tip number 4 is using scripts. So with scripts, you can define code in the script, and then within the object, instead of saying execute the code here, you can say call the script and execute the code there. So there are several reasons why you might want to use scripts. For one thing, it's a good way to handle redundant code. If there's code using a lot of objects, you can create a script with that code and all the objects can call that script. It also makes your code more readable. So if you have like 4 or 5 lines of messy code, it might not be immediately clear what it does, but if you put it in a script and call a script and the script name is good, then that would make the code much more readable, make it much more clear what's happening, and it kind of abstracts away all the details. And then the third thing, which is probably mainly my focus today, is called encapsulation. Now, there's more details involved as to why it's helpful, but the general gist of it is that encapsulation is, the idea is, if there's a task, you reduce the scope of who can be in charge of that task or that problem. So in this case, we have our level control, and we want all operations surrounding level control to be done within level control. We want to reduce the scope, we want to encapsulate the level control operations within the level control object. So an example of this is here in the player, we are working with a lot of level control objects variables. We're working with the beat levels array. We're working with level scores and level index and whatnot. So instead of modifying these directly here, we're going to do it within the script. So this chunk of code, I'm going to bump it over to a script, and we're going to call that beat level. All right. Before I create the script, I'm going to go ahead and right-click on scripts and do create group, and we're going to call this level control. So these are all the scripts which are operating within the scope of level control. So I'm going to create the script within here. I'm going to call it beat level. And then over here, I'm going to select all this, hit Control X, very dangerous, and then I'm going to paste it over here. And then to fix the formatting, a cool trick, I'm going to select all the stuff that isn't tabbed correctly. I'm going to hit Shift Tab to move it back. I'm going to modify this a bit. I'm going to put it within a with clause. So I'm going to say this is all happening within the level control. And then I do Select Tab for the formatting. And this will allow me to remove all these O-level control dots, because this code is being executed as if it's happening inside O-level control. Very cool. So now in the player, I can call beat level, and this will call the script, and this will be executed as if this code was pasted right here. That's all it is. So now let's do the same thing. We're going to convert this to a script, and it's called next level. I'm going to go ahead and cut to that. And here's what that would look like. Go to next level, does the same thing. Alright, so I want to find all the cases where I'm referring to O-level control and I'm saying dot. Wherever I'm accessing something within O-level control, I want it to be in a script. So I can pretty easily find all those cases by hitting Control-Shift-F, and then I'm going to type O-level control, and then I can convert all of these other cases to scripts. So here in the left pressed event of the button, we're essentially saying go to level, my level. And it's a little different from the other scripts in that it's not just paste the code and done. This script, we need to tell it which level we're going to as well. So what we were going to essentially want this to look like when we call it is we're going to say go to level, my level. So we're telling it which level we want it to go to. So let me go ahead and show you how we would write that. So this variable we're passed in gets read into the script through a variable called argument 0. So here I'm going to say set a temporary variable called target level equal to that input variable. Alright, now that we've done that, we can go ahead and cut this away, paste it here, and instead of going to my level, we're going to target level, which is the one that was passed to us. And of course, we can do it the width as well. Done. It's a little different having input, but having input is nice because it allows us to be a little more flexible with how much a script can do. You can hit refresh on the search, and we'll go to the next one. So the draw accesses two things within level control. It asks if the particular level is beat, and it asks if a particular level, and it asks for a particular level's score. This is also structured a little differently. So I'm going to start with beat. So this is going to need we're going to need to write a script for it, and we need to tell us whether that level is beat or not. So I'm going to create a script, and I'm going to call it is level beat. And this is different from other scripts in that first we had scripts that just did something, then we had scripts which did something and took an input. Now we need a script that does something and gives us something back to work with, because this draw event is not content just calling it. It needs to get information back from it. So what we do here is I'm going to cut that away. I'm going to say, let's see, this action needs an input as well, so I'm going to do it the same way we did previously, and also apply the with clause. Very cool. And then so this is going to be our output, whether or not the level this searching this array to determine whether or not the level beat will give us the output. And then in order to give that output back, we use special keyword return, and we say return like that. And then here we can say is level beat, and all good. I'm going to do something very similar with level scores, except I'm going to call it get level scores, and I'll do the whole thing in one go this time. And that's what that looks like. Alright, return back to our search. Now, the only time level control is referenced is within these scripts. Alright, now we're on advanced tip number 5, and this tip is to use maps instead of arrays. So let's talk a little more about the structure of arrays to kind of sell this point. The way arrays are structured, you give them a number, and then the array will give you back a room. So you're able to retrieve the room by passing in a number into the array. That's how arrays work. And this is great when a number is enough to describe which room you're on. If you just have like a linear series of levels, 1, 2, 3, 4, 5, and that's all there you need to describe them, then arrays are great, because that's what arrays are. They're a series of numbers corresponding to the actual elements that you're looking for. But in a lot of situations, that's not enough. So in the game I worked on 6 months ago, Binary Dash, there we not only have our standard levels, we also have hard levels and bonus levels. So the way we'd really like to refer to them is as not 1, 2, 3, 4, 5, but it'll be like normal 1, normal 2, hard 1, hard 2. That'll be a much better way for us to refer to them. And this comes up in a lot of games. If you think about the original Mario, like World 1-1, World 2-1. That's also a little different from what the standard array can handle. So we're going to convert this to using maps, and I'm going to cut away for a second, and I'm going to show you what this would look like if we used maps instead. This is what the syntax would look like for maps. So we have to first initialize it like this. So we set levels equal to a new DS map structure, and then we can refer to them very similarly to arrays. We just need a question mark in front to indicate that we're using the maps structure. And here in the comments I have the old array naming structure. This question mark is a shorthand in GameMaker. I guess the proper way to do it would be to use this function dsMapAdd. So this is saying dsMapAdd to add to the level structure element 0 what you want to add to it. So far I haven't shown you any benefit of using maps over arrays. The big difference is that arrays you can essentially use anything to index it by. So we don't have to use numbers, we could use strings. So if these are our standard levels, I might do something along the lines of normal _ 0. I might index it like that. And this gives us a lot more flexibility. So I'm going to go ahead and change all the rest of these. Okay, of course, every time we change these structures, we need to make sure we update it everywhere else too. And we're also going to need to update these beat level and level score arrays, because now they're also corresponding to things that are indexed by strings instead of numbers. So I'm going to hit Control-Shift-F, and I'm going to search for levels open bracket. This will show us everywhere we're accessing the array. So I'm going to go ahead and go through all of these and make sure that I'm going to update the syntax to use the string format. And I've updated them all. So if I refresh this search one more time, they should all be using that map syntax. And additionally, I guess I should look for level scores. Yeah, I need to update some of these as well. Alright, I've set up my beat levels and level scores as map structures as well. And if I do Control-Shift-F and look for level scores, you can see they're all using that map structure. And if I do Control-Shift-F and look for levels open bracket, then you see those also all follow the correct structure. So one thing I like to point out is that we are already benefiting from the encapsulation from the previous step. All of the changes, if you look through these, they're all either happening directly in O-level control, or they're happening in one of the scripts we set up for O-level control. And this is a very fundamental change to the structure of our level system, but we're able to do so while staying within a limited scope of the game. And all of the objects that are referring to level control, which would be the player and the button, they aren't any the wiser. They're just calling the same script. So that's why this is great. Okay, the way most of the changes end up working, let me go ahead and show you one of them. Instead of simply passing level index, now I'm adding the string normal underscore in front of it, and I'm stringifying the level index. That's how most of these changes ended up working. And if you want to see more details, again, the code's in the description, you can see more details. Now that we've made it more general using maps instead of arrays, let's go ahead and implement a feature and show how we can have a new level type. So what I'm going to do is I'm going to make another series of levels, and I'm going to make a series of hard levels, and we're going to index those as well. I have added hard levels. So if I head over to the rooms, you can see I made a bunch of new hard levels, and they're just the same as the other levels except more boxes to search through. Harder, right? The changes I've made, I've gone to level control. In the create event, I've added the hard levels, to the levels map. I've also updated beat levels and level scores to include items for hard as well. So this is where we're seeing the benefit of using maps, because this would be something that we wouldn't be able to do easily using arrays. Let's see, and if I head over to room start, I have also added another for loop to create a new set of buttons. It's pretty much exactly the same as the previous for loop, except I've changed the X value of the buttons and changed the text on the buttons. There, you're already seeing the benefit of using loops. I was able to make a new set of buttons just like that with minimal changes. Very cool. Alright, so now we've hit an issue with the button. The button, right now, I can only specify level index for it to point to, but we really need to give it level type as well, so the button can go to levels of both types, because right now it can only refer to normal types. This is a case where we're going to need to make changes in the button. Up until now, changing level system, we've been able to stay within the scope of the level control. However, when you have new features and you need things to be compatible with the new features, then that's a case where you would need to go outside the scope of level control and update it. So the button is a case where it needs to be compatible with the hard level features. So we do need to make updates there. Alright, so I'm going to specify a new variable in level control, call it my level type, and we're going to set that here as well. And then if we jump over to the button and left pressed, when we say go to level, we really want to say not just go to my level, we want to also say go to a level which matches my level type. Alright, so if I click on here, oh, here's another keyboard shortcut. I'm clicking there, I'm going to hit F12, and that'll take me right into the script. Really handy. Go to level is sort of in a predicament right here, because it used to always be called using one argument, but now we're passing in two arguments. If somebody says go to level 3, we still want to be compatible with the old system and just go to normal level 3. But if someone says go to level 3, hard, we want to be able to be compatible with that too. So there's like two standards that go to level needs to be compatible with. So I'm going to go ahead and update this to be able to handle that, and I'll explain it afterwards. Just like that. So target level will always be equal to argument 0. Cool. That's we can assume that. However, and then we have to set target type. And if there's two arguments given, as so, then we want to equal the second argument. So if they give us a second argument, we want our type to be equal to that second argument. If they don't give us two arguments, we're assuming that if they only give us one argument, then we're just going to default to normal. So that's the logic that we'll use here. This code will actually not work. There's a little adjustment that we need to make. So here we're talking about argument 0 and argument 1, and those are just old-fashioned variables. And the way GameMaker works, if it sees an argument 1 specified in the script, but somebody only passes a single argument, it'll throw an error. It'll say, this needs two arguments, because it sees the argument 1 in the script. It's not able to see that we can handle both situations. So what you need to do in GameMaker is you need to use different syntax. You need to refer to arguments as an array instead of variables, so just like that. And that will solve that issue. Alright, very cool. So now go to level can handle both systems. I'd like to make a note here. Now we have a legacy way of doing things where you just specify a number and it's assumed to be normal. And we have a new way of doing things where you can specify a number and a type. So by making this compatible with both systems, we're making our level system more complex and more confusing because we have to consider all those situations. So that's one solution, making this more complex. The other solution is to update any place that calls go to level with one argument. We'll consider that an unsupported way to use go to level. So we can update the rest of the game instead. So we can either update go to level to handle both cases, or we can update the rest of the game to only use the new case. So anytime you add new features, you're going to need to make this decision to yourself. In this case, we'd probably be better off making go to level only support two arguments, because I think button is the only place that calls it anyway. Just pointing out that that's always a decision you need to make whenever you add new features. Alright, the script isn't done yet, so when we go to a level, we set the level index to target level. So we update what the current level index is, but we need to have an idea of what the current level type is as well. So we're going to set level type over to target type. And I think that should be good for that. The next step that we're going to do is I'm going to go through all of these other level control scripts and see what else needs to be updated for hard. In some areas, like the button, we will need to update it. We will need to go outside the level control scope because it's necessary for it to be able to be compatible with the new feature. However, in other cases, we won't. Like in the player, if we go to the step event, this beat level and go to the next level, it's not passing anything in now, and I don't think it will need to pass anything. It can just rely on the current level type and level index from level control and use that to establish the context. So I'm going to go ahead and update all these scripts to be compatible. It'd be a good exercise for you to do the same. And again, look at the code if you have any problems. This is what it'll look like once you have it updated correctly. I went ahead and included the level type in the top left, and in the creation event of level control I've set it to none. So with this update, you can have the different buttons point to the correct levels, and they can individually be scored correctly. So I can go to level hard 2, I can search for the key, there it is, score should be 3. If I press escape, you can see the score is now 3 on hard level 2. Now we're on advanced tip number 6, last but not least. This tip is to use more level states. So right now there's 2 states for each level. Either they're beat or they're not beat. In this case we have yellow and gray respectively. But you know, in the real world, levels are often more complicated creatures than that. For example, in Binary Dash, I think we had like 4 states. So we had unplayed, played, locked, and beat. Those were like the 4 states. So I'm going to show you how you might update your code to implement a system like that. So the concept of beat, it really isn't specific enough for us anymore. So instead of calling this beat levels, we're going to call it level states. I'm going to update that down here too. So now when we're populating level states, it comes the question of what do we put there? So the standard Boolean type of true false isn't enough because we have more than just beat or unbeat. There's now 4 states we need to think about. So what else can we use? Well, we can use numbers saying 0 is unplayed, 1 is locked, etc., etc. But that gets confusing because we need to remember which numbers are which, and that can be kind of a pain. Strings are better, so we can say input locked or unplayed and whatnot just as a string. That's better, but still problematic because we might make maybe we make typos which can go unseen, more difficult to find, or we mix up whether we did caps or lowercase and all that. So that's also problematic. What if I told you that there's a data type made specifically for this situation and it's called enum? Enums are super cool, and I'm going to show you how to use them. So enums are a relatively new feature in GameMaker. I think they've been around a little less than a year now. If you have one of those old versions of GameMaker, maybe you're one of those people who's still chugging away with GameMaker 6 or something like that, you'd have to use macros. Actually, the GameMaker 6 probably doesn't even have macros. But anyway, if you want to learn how to use macros, that's also covered in my Loopize code tutorials. There's another plug, link in the description. You should check it out. Alright, so the way we make an enum is we say enum, we say the name of the enum, level state, and then we put all of the states within there. There we go, we've created our enum. And then we're going to set our level states initially to just locked. Just like that. And as an exception to that rule, we're going to set the initial levels to be unplayed. Just like that. Now when you do Control-Shift-F, once again, let's look for all the places where we refer to beat. And all these sections need to be updated to use the level states map instead of the beat map. So I'm going to go ahead and update that. And if I hit refresh, you can see those are all gone. Let me just show you one of the scripts I changed. So in beat level, this used to say set beat level equal to true, but now we're saying set level states, that state equal to complete. I'll let you refer to the code of the GitHub for the other situations. Alright, so now we need to update our button to implement this feature. So here we want to update our button to change color based on each of the states. But for that we need a new function. Right now there's only the isLevelBeat function, which will tell us whether or not levels beat, but we need a better function which will give us more information. So we're going to call it getLevelState, and we can call it like so. So I'm going to write that real quick. and it'll look something like this. Note that I'm not doing that whole argument count trick for this one because I've implemented this after the hard levels feature. So I can assume that anybody in the future, I can just require them to use both of these, and I don't have to worry about legacy. That way I can make it look a little cleaner. And I also did this cheeky one line rather than setting the variable to output and then doing a return. As you guys get better, I can try and throw more tricks at you. Alright, so this will be get level state, and we could just write 4 if statements for each of the different possibilities, but for these types of scenarios where you're checking against a single variable for all the different possibilities, that's the perfect scenario for a switch. I'm going to go write that out and show you how to handle this color changing with a switch statement. And just like that, that's what the switch statement will look like. We do switch, and in the parentheses we say which variable we're looking at, and then we add a case for each of the different possibilities. And I could add a default here as well in case none of the cases are met, but in this case I know they'll all be met. So for after each case, I set the color, and then the important thing to remember about switches, which is the thing people mess up most often, is that at the end of each case you need to have a break. If I take away that break, there'll be a bunch of strange glitches. There won't be any crashes or anything, but things won't work the way you expect, and you'll be pulling your hair out. So yeah, include the breaks. Yes, that's a switch. The next thing we need to do is we need to make some updates so that levels can enter the unplayed and played state. And I should be able to do that all pretty easily in the beat level and go to levels scripts. In beat level, I can not only set the current one to complete, but if the next one is locked, I can go ahead and set that to unplayed. So that's that. If the next level is locked, we want to set that to unplayed. Okay, and we want to write a very similar statement saying that if that level is unplayed, we're going to set it to played because we're going to it. It'll become played. Just like that. And then in the button, when I press it, we only want to call this go to level if the level is not locked. Just like that. And I think with that we can play the game. So they start out blue because they're unplayed, and these ones are all black because they're still locked. So if I play level 1 and I beat level 1 and I press escape, we can see that level 1 is beaten and level 2 is unplayed. That's actually a glitch. We need to update go to next level. Okay, I think I'll leave it to you to fix that. But anyway, if I click it from here, it should call go to level instead of go to the next level. And if I press escape right now, then it'll show up as played. Alright, so go to the next level. Homework. Go ahead, do that. So that is tip number 6 complete. We are essentially done with the tutorial, but there's a couple of things that have been irking me slightly. And since this tutorial has already been going on for a long time, adding a few minutes won't hurt. So I'm going to go ahead and tell you about these things that have been irking me, and we'll call them bonus tips, I guess. So, in level control, we are defining these arrays here, or the maps now, and the whole reason why we move them to here instead of in room creation code is so that we can easily update the level ordering. However, this current system is non-ideal. So, you know, if I were to switch these, I have to update the names like so, which is a little bit tedious. But let's say I want to do it like a bigger change like this. I wanted to move Lion to the first level. Oh my gosh, I need to update every single one of them. And that's a very tedious and error-prone process, as you're seeing as I'm trying to do it while talking. So I have a trick that I use to make that a little easier, and I'll show you that now. There we go. So I create this variable I. They're all indexed based on I, and every time I add a new thing, I do I++. So there's a little more code since I have all these I++s here. Maybe it looks a little bit messy, but it's so much easier. Like, I can just cut this out, and I can plug it in somewhere else, and I can do that without having to change any of the variable naming. So that's a little nicer. I'll leave it to you to update the normal, and let's see, the other thing that annoyed me, let's find a really bad example of this. So all the examples are actually pretty bad, but we're constantly doing this string manipulation logic over and over again. And when you have redundant pieces of code like that, those are prime cases for using a script. And in this case, it's not only redundant, but this is an error-prone thing. It's annoying. You have to remember to do this string thing over and over again. Making this tutorial, I had several times where I forgot to do this string cast, and it would give me an error, and I'd have some trouble figuring it out. So it was wasting a lot of time, me figuring out this string manipulation every single time. In my game, I would probably do something like get level key, and maybe I pass in level type and the index I'm looking for. I would do that instead of doing this manipulation over and over again. That's just me, and I'll leave that for homework for you as well. Alright, that is the end of this tutorial. I hope you enjoyed it. A lot of these, especially the tips in the basic tutorial, I'm sure a lot of you knew them already, but towards the end I felt like I was starting to rely on my years of experience with game makers. So with that said, I'm really curious about which tips you found useful, or at least at which point did the tips start becoming new to you. I'd be curious to know that, so go ahead and leave a comment telling me which tip did you find the most useful, or which tip was the first one that you hadn't heard of before. I'd be curious to know. In the description, there's links to the code as well as all of the plugs that I did to my various other tutorials covering a lot of these concepts. So feel free to check that out if you want to hear more. But other than that, thank you so much for watching. It was a fun ride having you here with me, and I'll see you guys next time.